Hello everyone, welcome to the first Voortman webinar of a series of Voortman webinars scheduled this year. Great to see so many of you joining us. Today it's all about milling, and although milling can be perceived as a challenging process, we're here to make it easy for you. A team of experts from Voortman Steel Machinery and Kennametal are eager to share their knowledge and expertise to help you take your milling process to the next level, and we hope to inspire you with valuable insights and tips. Before we get started, we are curious about your perspective on the benefits of milling. And right now a poll appears on your screen asking you, where do you feel milling adds the most value to your business? Are you feeling its influence mainly on the flexibility part, quality or output? Please share your thoughts through our poll. So, what can you expect during this 45-minute session? You will learn why you should use milling, the benefits of milling, and how the right tooling and parameters affect your output and costs. During this webinar, you can ask questions in our live chat, and our chat team is available to answer any question you may have. Some of these questions will be addressed by our speakers at the end of this webinar, so feel free to ask any question that comes to mind. We're more than happy to answer them. My name is Olga Jurjens and I'm the host for today, and I have the pleasure to introduce you to an esteemed panel of industry professionals. To my right is Stef Rohan, Product Manager Plates at Voortman, followed by Joey Scheur, Business Unit Manager also from Voortman, and to conclude our lineup we have Eva Maria Weber, who brings her expertise as Manager Sales and Technology Solid End Milling from Kennametal. First, let's get acquainted with the two companies. We've gathered here within the walls of the Voortman Experience Center. It's a showroom, demo and training center of Voortman Steel Machinery here in the Netherlands. And behind me you see some sturdy milling-ready beam processing machines. But on the other side of this building there are some plate processing machines capable of milling as well. Joey, can you shortly introduce Voortman?
Yes, sure. So Voortman is a provider of CNC steel processing machinery. And within those machines we incorporate a wide range of processes, such as sawing, drilling, shot blasting, painting, thermal cutting as well, but of course also milling. And that is the topic we're going to discuss today. If you look at the process of milling, then you see that the process is still quite in motion. So new tools are being added and new CAM approaches are also being developed to reduce the cost or improve the output of the process. We serve a variety of markets, and I think we have also a variety of people from different markets in our webinar. The markets what we can think of is the steel fabrication industry, steel processing and steel supply, but also the machinery and equipment market for customers just like us which make machines. Yeah. We are a global organization, but we also have local offices in the United States, but also in the most of the countries in the western part of Europe and as well in Southeast Asia. And most of those offices have sales, but also service and warehouses, because that is one of our strategic pillars, is that we want to optimize the service for our customers. But next to that, what is also important is that we want to automate as much as possible and maximize the output of our production lines. And you will see throughout our webinar that we developed quite some features within the milling functionality that are in those two strategic directions.
Yeah, it's no question that Voortman has a large global presence with an astonishing range of solutions for a variety of markets. But what about Kennametal, Eva?
Yeah, so Kennametal is one of the largest cutting tool manufacturers in the world. We are present in different business areas like aerospace, we are present in transportation, energy, but also in the earthworks. We have two segments, like we have metal cutting and we have infrastructure. And for the metal cutting segment we produce and we design our cutting tools ourselves, so like turning, milling, etc. And in the infrastructure segment we also provide tungsten carbide, or we provide carbides and wolframs, etc. So different kind of powders as well. And you can say that we are present globally, so we have around 60 different presences all over the world, and we have 9,000 employees. And also in Germany we have different plants where we produce our cutting tools.
Okay, thank you, Eva. With the first main topic, we explore why milling is a great process to achieve flexibility, output and quality. And this is a good moment maybe to see what you think about that by looking at the poll results. So we ask you, where do you think milling adds the most value to your company? And it seems that most of you feel that it affects the quality the most. But you may be surprised today about the benefits it offers for flexibility and output as well. Starting with flexibility. Joey, we spoke earlier this morning about the possibilities of milling for new ways of constructing and detailing. Can you explain more about that?
Yeah, so an aspect of steel fabrication is that the traditional way of detailing and the scarcity of welders, they create a bottleneck within the fabrication process. The traditional way of detailing uses quite extensive welding, and that puts pressure on the area in production where you already have quite some scarcity, and that creates then the bottleneck. With the milling possibility, you have a lot of flexibility in a new way of detailing or another way of detailing, and you see that as well in the picture that's now appearing on the screen. We can create copes or notches that allow for a tighter fitting and allow for more bolted connections. Now, with those bolted connections, you use less welding, and that puts at least less pressure on the welding area and reduces the bottleneck in the production. What's also important is that the use of bolted connections helps with the trend of circularity within steel fabrication. The circularity within steel fabrication is that you see a lot of people want to reuse building elements from previous constructions for new buildings. Now, with the use of bolted connections, that becomes easier because you can just demount the construction, make of course some adjustments that are necessary for a new building, and then reuse those building elements.
Yeah, you're speaking mainly about milling operations on profile drilling and milling machines. But we also have quite some group of plate processors and steel service centers within our audience today. And Steph, does milling also provide benefits for this group?
Yeah, sure. So milling also has the advantages for steel service centers because milling adds more flexibility in the operations of steel service centers. So then steel service centers can become a value-adding partner for their customers next to distributing smaller portions of materials to their customers. And then they can even become a one-stop shop for their customers. And they can then their customers can outsource their complete projects or assemblies or products to the steel service center, so value can be added. And we already have thermal cutting availabilities and functionality on our machine, and also drilling and countersinking, for example. But with the milling functionality, Voortman helps these steel service centers to take the next step in becoming a one-stop shop.
Yeah, and does that also mean that they can produce different kind of shapes with milling?
Yeah, it does, because with milling, basically all limitations of hole diameters or flexible shapes are gone, because with drilling you of course have the limitation of your maximum drill diameter, but with milling you can create any contour, any hole size you want. So also for non-typical features like counterbore holes or slotted counterbore holes, they can be created using milling, because with milling you can create pockets. And normally to produce those kind of features you have to invest in tooling, which can be quite a big investment for steel service center if the tool is only used for one order. But with milling you only need a couple of mills and you can create whatever you want. So this makes them really flexible.
Yeah. And they can take more jobs then, and then the diversity of jobs increases. And I can also imagine that steel service centers must encounter different material types then. How does milling fit into this story?
Yeah, they want to be able to machine any kind of material, of course, again to add more value for their customer. But milling, that is possible. So with drilling you have limitations because the speeds and feeds are connected, and for sure with tougher materials this limits you to produce those to machine those materials. But with milling the speeds and feeds are disconnected, so then you are actually able to process and machine any kind of material you want, even the toughest ones.
Yeah. And Eva, do you recognize this trend of combining technologies and the multi-processing approach which Steph speaks about?
Yes, definitely. So we also see that hybrid processes are coming more and more. And when you, for example, combine additive manufacturing, so kind of 3D printing, with subtractive machining processes, so where you remove material like milling, and then yeah, you can see the benefits of both processes, and you can really take the advantages of each process out of it. And for example, in 3D printing, you have the benefit you can produce very complex surfaces, shapes, etc. But in the end, you will not have the surface tolerance you need. And when you machine in the end the key surfaces, then you will get again these tolerances, and you will have both advantages in one process.
Yeah. It sounds like milling provides a high degree of flexibility to allow companies to create different shapes, different connections, and machine different materials. But what about the quality of the mill parts? I see plate parts here laying on the table. I have a beam part here, and I see very smooth milled surfaces. Steph, can you explain more about the quality of milling?
Yeah, I can. So quality, the main reason to choose for milling is quality, of course, for sure on our plate processing machines. Because as I told before, we combine the thermal cutting possibilities of a plate machine with the milling possibilities. But for thermal cutting, we comply to the ISO 9013 Class 1 standard, which means that we have tolerances from approximately plus minus 0.5 up to 1 mil, depending on the product's length. But with milling, you can achieve better quality if your product or your end customer asks for it. So with milling, you can significantly reduce those tolerances, and then it's good enough.
Yeah, that makes sense. But regarding the output, it seems that milling is significantly slower than cutting. Doesn't it make it less appealing then compared to cutting when it comes to output?
Yeah, indeed, milling takes more time than cutting a contour. But what we have on our machines is the unmanned mode functionality. And what it basically is that when you turn on that functionality in the quick menu of the controlling software, is then the machine will only produce the machining functionalities which can be done without an operator present at the machine. So for example, the drilling and milling operations will then be done overnight in the unmanned shift. And when the operator then is back in the morning, he can be there and cut the products because the products are ready to be cut. And the operator will then be there to control the cutting process and to unload the products. And yeah, so this still helps you, although milling is slower, to increase your annual output.
Yeah.
And the same can be said for the beam processing lines. Also for beam processing, cutting of course is faster. It's just a faster process for creating those copes and those flange removals. But also there the nuance has to be made that the machining process itself lends itself quite well for unmanned shifts or low staffed shifts, and that makes it attractive.
Yeah. Yeah, and regarding the output, does Voortman try to further improve this by developing more smart software features?
Yeah, we do. So last year we introduced hybrid milling in our controlling software. And what hybrid milling basically does is that it will first cut away a large portion of a contour, and then it will only leave like 2 millimeters of material, which will be milled away because it's a heat affected zone. And then you can achieve a great quality, but you can reduce your processing time. And next to reducing the processing time, you can also reduce the wear of your milling tool.
Mhm.
And this together will lower the operational cost of your machine, and in the end it will lower the cost per part.
Yeah. Okay.
And on our systems we also support the stitch functionality. So you can imagine that some contours do not require high quality. You use the milling process mainly for its flexibility. One can think about a contour that is used for a passage, for piping or electrical works. Now those contours can be left with stitches, so our tabs on the outside of the contour, and then we don't remove the entire inner contour, but we just mill only the outside edge and leave stitches on two sides of the contour.
Yeah.
What is important is that those stitches still have to be manually grinded away, but the software, we try to think about that in advance when we develop the stitch functionality, because the stitch functionality also tries to minimize the stitch width, but also the stitch depth. So the mill will still try to remove a bit of the stitch, so the grinding is minimally afterwards.
Yeah. Okay, clear story, Steph and Joey. It seems like there's a lot of built-in intelligence involved here. And milling provides a lot of benefits in terms of flexibility, output, and quality. And that's maybe a good question to those of you who do not incorporate the milling process in their production process yet. Why don't you implement it? We are very curious, and that's why a poll appears on your screen right now, asking you, what prevents you from implementing the milling process? Is it because you think your operators don't have the knowledge about the process? Do you think it's an expensive process in general? Or do you think it requires a lot of programming? Or don't you have machines with milling capabilities? Or is it maybe that you don't know why or when you should use milling? Please share your thoughts, and we come back later while we just move on. Steph, we saw all kind of milling videos passing by, and with all kind of movements, and I can imagine that it requires a lot of programming. But how easy is it to program milling on a Voortman machine?
The nice thing with our machines is that basically everyone can mill, so you don't need a lot of programming knowledge or processing knowledge about milling to start milling. And our goal is to automate the process coming from cut, from going to the processing approach, so CAM, as much as possible. So I can explain both processes for as well beam machines and plate machines with some videos. So first, you always have to start with a product which has to be milled, and you can create it in CAD, for example, in Solid Edge. And in this step, you don't need a lot of processing knowledge. What is important is that the product can be made using milling, of course. So one of the rules is that the minimum radius in your product has to be bigger than the minimum mill available in your shop.
Yeah, and so once you identified which contour can potentially be milled, how does a Voortman machine know whether or not the contour should be milled by the machine?
For beam machines, most of those machines can determine itself whether a contour has to be milled or has to be cut, for example. So not always you have the combination of milling and cutting functionality. So in that case, when the diameter of a hole is too big and it can be drilled, or it is an odd shape, then the machine will automatically start milling that feature to make sure that that feature has been produced.
Mm.
But also in multi-system integrations, you can combine the drilling machine with, for example, the thermal cutting machine, the V807.
Mm.
And in that case, odd shapes can be created with as well thermal cutting as with milling. So in that case, the work preparator has to specify if he wants the contour to be milled or to be cut. And for plate machines, it is a bit different, because on the Voortman plate processing machines, we always combine the milling functionality with the thermal cutting functionality to create flexible contours. So then in SigmaNest, the work preparator can specify for each contour whether he wants it to be milled or he wants it to be cut.
Yeah, and does he then only invest time in specifying which contour should be milled, or does he also invest a lot of time in programming?
No, he doesn't need a lot of time for the programming,
Mm.
basically nothing, because we have the automatic toolpath calculation in FACAM. So once a product is ready and it will be uploaded in FACAM, then FACAM will automatically start calculating the milling strategies, the ramping cycles, but it will also select the right tool to perform the job. So no knowledge about the processing technology is necessary at all.
Okay, so then it's time for some action, and you can just start processing with a simple push of a button.
Yeah, indeed. So as I said, everything is calculated, and the cycle list will be generated automatically. So the operator can press the start button, and then we can start milling. So this fits automatically, this fits perfectly in our one-button philosophy, which Voortman has.
Yeah. Okay, great. And let's say that a customer wants to change or set their preferences anyway. Is that even possible then, Joey?
Yeah, so we have some preferences. For instance, we mentioned already the stitch functionality, You can define as an operator or preparator or company, define where you want to apply stitches. So what kind of contour size you feel that stitches should be applied. But next to that, we also have the possibility to enable or disable finishing passes. So the same background applies there. If a contour does not need a high quality, then a finishing pass is obsolete. It's not required, and it takes time, which you don't want. You want to maximize your output. Now, for those that don't understand what a finishing pass is, milling exists kind of out of two kind of passes. The first one is a roughing pass, and with the roughing pass, the maximum material is being removed by the mill. But there's quite a lot of stress on the milling bit. Then at the end of the roughing pass, it tries to leave at least 2 millimeters, kind of similar as the hybrid milling approach. It tries to leave a bit of material at the outside edge, and then it will remove that outside edge with a finishing pass. Because it just only removes a small bit of material, there's almost no stress on the milling bit, and that optimizes the quality of the contour.
Okay.
But like said, a milling pass is not always required. The quality is not always required to be that high. And in those cases, you can just disable the milling passes, and then you have a higher output.
Yeah.
Yeah, and also with hybrid milling, the operator or the customer can choose to enable hybrid milling or to disable hybrid milling in the quick menu of FACAM. And when it's enabled, FACAM will automatically determine whether a contour can be produced using hybrid milling. And if it's not possible, it will just use the normal milling method to mill away that contour.
Yeah. Okay, sounds like milling is made very easy. You create the contour in CAD, specify what needs to be milled, then FACAM automatically calculates the milling pads, and you can start processing. I think this is very unique in the market then. And now that you know how straightforward the process is and how easy it is, maybe it's a good moment to show the poll result we just asked you to fill in. And we asked you what prevents you from implementing the milling process in your production. And I see that most of you who do not yet implement it think it requires a lot of programming and that it needs a lot of operator knowledge. But as you just heard from the story Steph and Joey just told you, it's very easy, so you can start with it today. So the next topic we will touch is the tooling part, which is a very important topic of milling as well. I can imagine that you are overwhelmed by the array of milling tools available, and that's why Eva and Joey are standing at the machine right now to tell you all about the tooling part of milling and which tools to use in specific situations.
So if we speak about tooling, we can distinguish two main parts. One is the tool holder, and the other one is the mill. What is important already to mention about the tool holder is that Voortman specifically went for a so-called cool bore holder. Now, what we see about those cool bore holders is that we have those channels on the side of the mill, and they redirect a high-pressured airflow towards the tip of the mill. And what is important about that element is that it removes the chips of the process. And what you see with a lot of features that are made on Voortman machines, those are narrow holes, narrow slot holes, and those contours are narrow, and that means that chips easily clog within those shapes. When that happens, those chips will be recut again by the mill, but they can even melt together with the mill itself. That's quite different to general machining centers, because general machining centers often they machine the outside parts of a part, so chips can easily exit, and that's quite a difference with the application on our machine. What's also important about these holders is that because we have those channels on the outside of the holder itself, we have a full mill without any cooling channels. So it's a full solid carbide mill without any cooling channels. That makes the setup quite rigid and quite stable.
Yeah, and that's kind of the Kennametal's philosophy as well. So we really want to have, in some kind of processes where we are already on an unstable cutting condition, we want to have the tool rigid. So we do not want any internal coolant challenge. We normally cool through the adaptation, so like with liquid or with with air coolant, and that really helps to have a vibration-free process. And another important point, of course, when you use air or liquid is to remove the chip safely. And in addition to that, we design our tools that way that we design the flute space accordingly so that we can effectively remove the chips from the cutting process.
I think what you already heard is that Eva mentions the element of stability, I mentioned the element of stability, and stability is of course key in the milling process to extend that tool life. What you guys see here on the table is that we have a standard commercially available holder, and then we got a Voortman design tool holder. And what we try to achieve here, Eva, is that we have a standard commercial tool available, a small mill, and we have of course our machine characteristics, so where the drilling head can still reach the material, for instance with a clamping system or with certain beams. But we try to optimize the rigidness between the drilling head towards the tool. So minimize the length of the tool holder and make it as rigid as possible. And we see that with these kind of tool holders, we can increase the material removal rate by even 60%.
Oh, okay. Yeah, and that's quite important. And for us, we are always looking on the adoption side, but we always look also on the tooling side. So the combination for us is very important that that fits together. And choosing the right cutting tool is also for our customers the key goal. And sometimes HSS is still the weapon to go, because HSS can grant you a very stable, secure process, but you might not be so productive. And at Kennametal, we use a lot our carbide tools in combination with really modern surface technologies to have a good coating technology, good coating tools. And when we combine then with the right adaptation, so with a very stable adapter, and we also can maintain the tool life on a very high range. And with Hobby 1 series, we have now a very flexible tool as well. So also for these beam machining operations, for really thin blades, it helps you a lot, because you can use one tool for several applications, and you do not have to switch the tooling. And we have a really stable and rigid core design. We have, as I said, a proprietary flute design for that. And what is very, very important, that you have that center cutting possibility. And that center cutting possibility helps you in all the Z-axis operations, which you need a lot in blade machining.
Yeah, because that's important that you mention that, Eva, because we often get the question from our customers, can I also use solid carbide or carbide tipped mills instead of solid carbide mills? Now what's important is that these Harvey mills, they can plunge directly, they can work with really short ramps, so they are a solution that is quite flexible. So all kinds of features that are made on a Voortman machine can be made with one mill. Now with those carbide tip mills, in general they need longer ramps, they need some area where they can openly enter the material. Now in most applications that is not the case, especially not with beam machines with flange removals, for instance, we need a plunge. But with hybrid milling, which is a different kind of setup we discussed in the webinar, you have an open area which is already removed by the thermal cutting. Now with those kind of applications, a carbide tip mill could also be a weapon of choice.
Yeah, definitely. And now we have had a look at the tool holder. We have discussed the machine tool. We have discussed the cutting tool, but what's also important to really choose the right cutting parameters. And that's where we work really close together with Voortman, that we also give our customers secure parameters. And when you have maybe a very stable condition where you can be very productive, then you go high with your feed rates, with your cutting speeds. But when you're in a more unstable condition where you have thin plates to machine, then we normally reduce the feed and speed rates. And that's very important, to give the customers a small range of parameters where they can work in. And for that, we have prepared a small video today where we wanted to demonstrate that. And you can see here in this video, in the bottom, the parameters have been chosen a bit more faster, more productive, but you can see, okay, for that situation, it's too much vibrations. You can see that on the glass, it's moving. And on the top, you can see where we reduced the cutting speeds a bit, so that we have really also reduced vibrations to guarantee a safe process. And I hope, that explained a bit today how we choose our adaptions, how we choose our cutting tools, and to have a secure process for the customer.
So, we spoke about all kind of aspects, know-how, software features, tooling of the milling process today. But maybe we have some other relevant topics which might interest our audience as well. For example, Eva, what's your view on the future from a Kennametal point of view when it comes to milling?
So we see that more and more different material types are coming, and also material combinations, and which therefore challenge our customers. And for us, it's very important that our tooling can provide solutions for all these different material types. And as well, we want that we can, with our tools, rough and finish in the process, so that they only need to use one tool for the whole combination on the process.
Yeah, and Steph, do we foresee even more applications where milling could offer benefits?
Yeah, we do, and we can completely recognize in the story of Eva that our customers want to be able to machine hard-to-machine materials. And currently, with the drilling and thread tapping operations we use, we have some limitations in tougher-to-machine materials. So with milling, so for example, with thread milling, we can still apply those features in those tougher-to-machine materials. And also, if you look to countersinking, for hard materials, it's really hard to make a countersunk hull. But when we use milling, we are able to produce countersunk hulls in hard docks. So milling has still a lot of applications which we can introduce in our machines, and it will also make our customers even more flexible.
Yeah, and speaking about the flexibility, we saw all kind of shapes that could be created with milling. Can it also be created with thermal cutting, Joey?
Yes, indeed. Yeah, that's also an option. So Steph already mentioned that we also have an 807 in our portfolio, which is a robotic thermal cutting machine. With that machine, we can create a variety of shapes, even more than what we can do with milling. But next to that, the machine can also do four-side layout marking. It can do kind of the same, can create the same features as a sawing, drilling, milling, and punching and shearing line, but then within one system, within one machine, with a really small footprint. And I think for customers that where the majority of the production or a large portion of the production includes copes, notches, weld preparations, but also for customers where flexibility is kind of a prominent factor within their purchasing decision, then the thermal cutting robot would be the way to go.
Yeah. Okay, thank you. Then it's time for the questions, or at least write down your final question, because now's the moment to do so. We are going to watch a nice video of the Voortman machine showing off their milling capabilities, and we'll get back to you in a minute. Okay, let's have a look at the questions which came in. I see that the first two questions are quite related to each other. And the first question is, what is the tool life of a mill? And the other one is, how can you see that a mill is worn down? Yeah,
So I think I can answer these questions. The tool life of a mill, it's quite difficult to define because you have so many parameters coming in. So you have the machine, you have the adapter, you have the tool itself, but also the material to cut. But together with Voortman, we really define a process which is stable, which is defined for the customer, and we can also say that the material is defined, and therefore we have around 1.5 hours tool life of the end mills. So that's quite clearly. And how can you see that a mill is worn down? That's also one point that you have to define maybe before you go in your process. So you say, okay, we want a constant tool wear of around 2/10 or 3/10 on the cutting tool, on the cutting edge. So that's the positive wear you can have on your tool. But on the other hand, you can also have some kind of notching or even tool breakage. And that's something which you do not want to have
No.
on your cutting tool. And that's also where we have been working with Voortman so that that does not occur at the customer.
Okay, thank you. Next question is, are the sparks normal with milling or is it due to tool life?
Yeah, so I can pick up that question. So indeed, we saw in some videos, we saw some sparks. Now what happens with milling is that it works in passes. So in different depths, you try to go to the maximum depth of the contour. And especially at the end, when you fully plunge the material, there's almost no material left. And because with milling, a lot of heat is generated. And you also want to have that heat within the chip. Especially, of course, with that lost penetration, when you have almost no material, all the heat goes into that chip,
Yeah.
and then you get those sparks. So it's quite a normal phenomenon, but it's even better for tool life because you want that heat within the chip and not within the tool itself.
Yeah.
And that's, I think, is also it's building up on that tool evacuation, what we already discussed. You want, or the chip evacuation, what we already discussed. You want to have those chips away from the process area.
Okay.
And that's really important because then you remove the heat and then you extend tool life.
The next question is about hybrid milling, where we also spoke about. The question is, do you need to remove the cut inner shape when using hybrid milling?
I can answer that question. Yeah, indeed, you need to remove the cut inner shape, indeed, because otherwise, when you will start milling, you will have a jam between the inner shape and the mill, of course.
Yeah.
And we also have an operator dashboard feature in VCAM. And that operator dashboard will show the operator when he needs to be at the machine to perform a manual action. And one of those manual actions is removing the inner contour with hybrid milling. But it can also be that he has to brush away the chips or has to remove a product before the machine can continue. So, but yeah, the basic answer on this question is yes.
The next question is, how does Voortman support customers with the milling process?
I can also answer that question. Yeah, as Joey already mentioned, we have an after-sales department in as well Europe as in the United States, with also sales engineers on the parts and consumables department, and they can help our customers to select the right tooling for their job. But they can also give them advice in how to mill, of course. But I think in this webinar we showed that milling is quite easy on our machines,
Yeah,
so that
definitely.
you don't need a lot of support. And I think together with Kennametal, yeah, we always try to improve and introduce new applications and to do some testing.
Yeah,
So
definitely. So that's also very important for us that we work very close together. And if there are any problems also at the customers, Voortman reaches out to us and we give the most actual data to them. And I think that's a
that's
good way to
thing.
go. Yeah.
Yeah.
Yeah, and I think it's important is that we deliver the entire package. So it's tooling, machine, and parameters. So it's it's complete because the parameters depend again on tools you select and the machines you have, because they're even machine dependent.
Okay. The next question is, what happens when the table is damaged with thermal cutting? Usually tables are not flat and have a lot of scrap. How does this affect milling and the milling tool?
Yeah, so that's quite a good question. So what we do on, for instance, a 310 that has a combination process of thermal cutting and milling, we measure the plate from the top side with a clamp. So by that we know we have a kind of a reference point of where the plate starts, and we use that for milling the pockets. If the contour is fully penetrating material, we always have an additional depth, because what can of course happen after a while, and that's what we mentioned about the unmanned shifts. You want to work with minimal staff. Now, after a while, a lot of chips can still be a bit on the plate, so the clamping measurement will be affected by those amounts of chips. Now, with fully penetrated contours, we have that additional depth to correct for that. If you have a lot of pockets and they have to be quite accurate in depth, then it is important for an operator to be present to remove those chips, especially if you have a lot, because then you get chips being collected on the plate surface.
Yeah. Okay, that makes sense. The next question is, can milling shapes be programmed in Lantec?
Yeah, that is possible, because all of the milling technology is within VCAM, so it is not within the nesting software. So basically the only thing we need to know from a nesting package is whether a contour has to be milled or not, and then VCAM will determine and calculate the toolpaths, etc., as we mentioned in the webinar. So yes, we can, of milling shapes can be programmed in Lantec or other nesting programs.
Okay, the next question is, could you elaborate about the tables? What types should be used for milling? Slats, square grid with aluminum, inserts, or other?
Yeah,
What is the best?
kind of built up on the last question I answered on. Yeah, so it's really important to have stability. I think we mentioned that throughout the webinar. And we did quite some testing as well with the standard slat tables that are used on only thermal cutting machines. And you see that especially if the grid is not stable and it's vibrating, then that's hurting your tool life. So you want quite a stable grid. It doesn't per se have to have aluminum inserts or other inserts, because what you will see in practice is that most of those inserts are thermally cut away after a while, and people are still using the tables. But especially that square grid, that's making sure that the entire table is rigid. That is really important for the process and for the tool life itself.
Yeah.
So if you talk about the advice, I would say a minimum would be to have at least a square grid.
Yeah, okay. Another question is it possible to mill a bevel on the profile?
Yes, it is possible. So on the beam processing machines, we have a milling package, and if you have the right milling package, you can create weld preparations on profiles, how you want. But of course, it's depending on the shape of the mill, what kind of preps you can create. But yes, it is possible.
Okay. And the last question I see on the screen is it possible on our V631 to machine V631 machine to pre-drill a hole with a drill?
Yeah, so that's an interesting question. Eva and I talked already about the plunging functionality of the Kennametal Harvey. What we want to achieve with the milling process and with adding all those features is we want to automate the process of getting from, indeed what Steph also said, going from a CAD model to a processing approach without having a lot of manual intervention. And the first way forward was to keep it simple and make all those shapes automatically. And that could be done with the Harvey mill, with plunging. I'm also looking at you, Eva, but I think the pre-drill indeed could most likely extend the tool life.
Yes, definitely. So when you pre-drill, of course, you can use your tool longer, but you also would have a combination of tools, and that's sometimes what the customer does not want.
Yeah. So it makes it indeed a bit complex. Perhaps for the future it could be an extension. Right now we don't offer it, so we always plunge. And with the majority of contours where you have enough room for a ramp, that is also certainly not a problem. But in the future, indeed, that could be an extension that we could add to our machines to even optimize the tool life a bit further.
Yeah.
But I think that's also what we said at the beginning. The milling technology is not standing still. New tools are being added, also by Kennametal, and we are constantly adding new CAM approaches, and this perhaps could be one of them.
Yeah. Okay. I think that were the questions, and that brings us to the end of this webinar. I want to thank you all for watching, and also thank you to our speakers. If your question is not answered yet, we will of course come back to you by email. And if you have any other questions, feel free to reach out. And we have more upcoming webinars this year, so keep following us on our social channels because we want to keep you up to date. And on the next page, you also see some other relevant topics related to today's discussion. Yeah, and we hope to see you next time. Thank you again for watching.